In question 2, we start off with trigonometry, and I've got sine of 20 degrees is equal to p, and I need to determine sine of minus 20 degrees in terms of p. So we're going to have to do a bit of reduction to pull this off. So I'm going to get a cast diagram going. And to set myself up for reduction, I need to add 360 here, so that I can transform it into sine of 360 minus 20, and now I'm in the 360 minus quadrant, so I can tell whether it's positive or negative. Now if I have a sine over there, and if I look at this quadrant, the 360 minus quadrant, only cos is positive here, so it stands to reason that sine will be negative there. So we simply just transform it into negative sine of 20, just like that. And then sine of 20 is equivalent to p, so I can swap that sine of 20 out for a p. And the negative will just stay in front because it's still being multiplied by that. And there you have it, there's your final answer. And your 2 marks come from the correct reduction with the 360 minus quadrant and the correct answer of minus p. Next up, we need to get sine of 160, so I can smell some more reduction coming, my bro. So if I have a look at the size of 160, it's in between 90 and 180, so it's going to fall in the 180 minus quadrant. So I want to transform this 160 into 180 minus something. Okay, so I think 180 minus a sneaky little 20 will get the job done, my bro. So you just slap in a 20 there, and you've just got to make sure this is equivalent to 160. 180 minus 20 does give you 160. Okay, now we can reduce. We're in the 180 minus quadrant, so sine is positive over there. So this whole mess will just transform into sine of 20. And now we've successfully reduced it. Okay, sine of 20 is the same as p, but so we're going to switch it out once again. And we're left with a toasty little p as our answer, bro. Okay, your 2 marks, much like the last question, come from the reduction as well as the final answer of p. And next up, they ask us for 1 minus sine squared of 70. Okay, so I smell something. Okay, before I show you what we're going to do, we've got to deal with this square. So we're going to put it on the outside like this. We just wrap sine in a bracket and put the square on the outside. And now, you see 70 and 20. If I add those numbers together, it gives me 90. And what that triggers in my brain is to think of cofunctions. So your cofunctions are the 90 minuses and 90 pluses. So what I'm going to do with the 70 is I'm going to break it up into 90 minus 20 so that I can use a cofunction. And after I break that 70 up into 90 minus 20, I'm going to look for the cofunction with sine of 90 minus. Hey, how's that, but? Right, so it's just going to change to cos of theta. So let me just walk you through how it works. So this theta can be anything. I can change them both to 30s. And presto mundo, we've done cofunctions with numbers. So applied to our scenario over here, this sine of 90 minus 20 will simply just change into a cos 20. Again, once I've got the cofunctions out the way, I'm going to distribute the square back in, so I'm going to move it back there. And now I can smell something. Can you smell it? It's an identity, but she's on the loose. So if I have a 1 minus cos squared, if you look over here, 1 minus cos squared will change into a sine squared of that same angle. So this whole thing will change into sine squared of 20 using this identity over here. Again, then we're almost home safe. Okay, I'm just going to gently walk you through how to deal with the square, because we know sine of 20 is p, but the square, we just take it to the outside like we did earlier. And when we take it to the outside, we can make the replacement. So sine of 20 is the same thing as p, so we'll change that guy to a p. And the square will just chill on the outside, and then I can get rid of the brackets. There's no need for them anymore. And we've arrived at the final answer. It's b squared. Alright, let's have a look at the marks. Okay, so 1 mark for the cofunction, 1 mark for using trig identities, and 1 mark for the final answer.